So to demonstrate how these alarm templates are configured, I'm going to open up the alarm report template in the Template Studio. And you can see that when I open that up, we're in a very Excel-like environment, but this is actually a standalone application packed in with XLReporter. It is also available as an Excel add-in if that's preferred. But if you're familiar with Excel at all, you'll immediately recognize some of the features of the template as it's laid out here. There are cells with their own formatting, there are formulas, there are chart objects like this Pareto chart from the alarm source report. But the key aspect of driving a report using the alarm management connector is the specialized data connection that's configured for this. And if you've used XLReporter with a process historian or with a PLC, you're probably familiar with designing templates and using the connections interface. But the connection for an alarm management module data connection looks different than a standard XLReporter connection. So you can see when the connection group is opened there, we can see the subreports that are laid out across the different worksheets configured in the template, and for each subreport we have configurable parameters. So if we look at the one on this sheet, which is the alarm count subreport, you can see that this one returns the new alarm frequency over each module and attribute, and those are ordered by the count in descending order, which obviously is what we want if we're looking at the top bad actors. And you can see that the attributes are shown individually, but they can also be combined for each module if that's preferred. And then on the columns tab, we can see the ordering of what is mapped into the worksheet. So if we just go back briefly to the report tab here, you can see that count is placed onto alarm sources B33 right here beneath the module node heading. And if we look into the details of that subreport, you can see that the columns in order are module, description, attributes, alarm quantity, average per hour, accumulated total, and accumulated percent and area, which maps directly from this list to the headings on the worksheet. So you can see how these connections are mapped from this configurator into the template. Now we also have the concept of operator positions, and in ISA terminology, a position is a collection of areas. And by default, you'll notice that the report is generated for all areas, but we can actually design custom groupings of areas or custom positions. So let me add one here. And I think the data that I'm working with is from a brewery, so I'll create a position called Brewmaster, and then I just add the areas I want included in that just in order there. So if I bring over, I have an Excel workbook here that's got a listing of my areas. I just pulled this by querying it out of the SQL database. But let's define the Brewmaster position as everything from fermentation through K-logger. So I just add that to the position configurator. And then now I can generate the report for this custom position. But you might be asking, when the reports run, how is it determined whether it's going to be run for all areas or whether we run it for just the Brewmaster position? Well, I'll show you that momentarily here. So from the context of the on-demand reports client that we were initially using to view these reports, the user would be able to select the position they would like to run the report for, and that is configured from the on-demand designer. And the on-demand designer can basically be thought of in two stages or two areas, basically. So there's the variables tab, which allows the user's controls to input variables into the report. So for example, you recall that we were inputting start and end date, and those are controlled by a calendar control. However, what we really want to do is have the operator of the report select the position, which can be done by adding a parameter panel. And the variable we want to control is position. And I think an appropriate input mechanism for that would probably be a drop-down list, where the user just picks the position they want to run for. And we can then build that list here. You're going to have to stick with me for a moment here because I'm going to get a little bit obscure. But the way that the position list is driven is by a zero-based index. And the way that the control list works in the on-demand client is by providing a display value, what the user sees in the dropdown, and then a background value, which is what's passed through to the report. So in this case, all is going to be position 0. It's the first position on the list. And brewmaster is going to be the second on the list, which is position 1. We can also set an initial entry. So I think it'd probably be appropriate to have all be the default. And then we just insert the position custom list control into the on-demand designer. Save that and close it. And then we can test this out by running the preview tool here, which just links back into on-demand. So if you see here now, we have a control for the position. And if I run that, we'll flip over to the alarm source page, since that's where we were when we clicked preview. And you can see the alarms are generated, or the top alarms are generated for all positions. And if I select brewmaster and refresh again, you can see that the data shifts slightly because it's only considering the areas relevant to the brewmaster position. And now that's how generating these reports and how customizing the input controls would work for an on-demand report like this one. Next, we'll take a look at how these reports can be driven automatically.